So the idea right now it will be to start with the model evaluation. At least we can have like a proper metric, not just in the level of 1 on 0 prediction, but the complete event. So I have a trained model, we have our true and predicted. I would like to see the segment this delimited by all of the contiguous true predictions if they actually match with the true ones. So let's create a function. Let's say binary array to events. We have it's not a binary array, it's like let's call it predicted, and we have our confidence threshold, and we are going to return this is okay. I think the implementation is, I haven't looked at it. So we just start by iterating. The binary array is greater if that is none, then is not. Okay, this should, let's create test model evaluation. I think it is okay. No, we have, if the value is greater than the confidence is and the start is not set, it initializes the starting point. After there is a close, if we have a start, we append until the end. The end should be not inclusive, right? Because it should be I minus 1. We have 0. Something like this, probably. If not, it put the last one, okay, minus 1. So let's create just a simple test for this. Let's use 0, 0, 0.3, 0.3, 0, 0, 0.5, 0.4. We can have something like this, and we should expect from ISMP our expected events will be 0, 1, 2, 3, 4, 5, 6 to 7. If we do UV add, it's like this. Probably yes. Can I increase a little bit this font size in here? Preferences, settings. Font size 16. Is it bigger? 18. So UV run by test. Okay, let's put it greater or equals. Is greater or equals. So we have this thing. Okay, if this doesn't end, we have this. This is okay. We can have with another strange case. I don't. Okay, it's okay. So we have this function in which we have the predicted. Do I have this is loaded? If I would do iPred, okay. iPred 0.2. I'm not going to remove everything from here, but maybe it's a bit slow, no? How many events do we have? And we did true. So one thing to consider is okay, see, we have a lot. This fragmentation of these events. I was expecting, but there is a problem also here because we need to do something else because here we are dealing with overlapped patches. So we should how we can do that. So if we get this is at the level of the overlapped windows, but we need somehow to combine these windows. It's kind of saggy, but for this. So how do we create a data set? We have we are using the data set time series data set from array. But we have this information, so let's see if we can okay, first of all, have this. I should have some function for def predict single study, something like that. We have the but I should also know how to pre-process it. Are we saving the preprocessor? We are. So we need. So so we have a path. We are going to load the model, load the preprocessor, which is okay. That the preprocessor is of the data set. I don't know if I like that. What does the preprocessor do? Study preprocessor as per time series max scalar. this is something related to the data set and not the preprocessor, but it's okay. Okay, maybe we can live with that. But I should receive the preprocessor, the file, so I have let predict single study, receive the model, the preprocessor, and the study. So how we have to open it? We have the transform, and then we need also the configuration, which is this also in the data set. The data set configuration. Now wait, do I need the knowing the stride? It should be useful, I think. So no, I need a way then when I export the model to have all this information together. Otherwise, I have to get some pieces from each side. So I need to save. So I need to save preprocessor, save the model, save the data set metadata for knowing the input shape and stride. But this is the dataset configuration. So let's see, maybe I can make an object. We have load data. So can we create a class for this with everything? Let's see. So let's create a data set. We're going to have the splits. Preprocessor. Maybe we can lazy load it. Maybe the metadata is okay, and the other things are lazy loaded. Put self train ds equal none. Get training split. If this is none, we are going to val test get preprocessor. I now have to know how to load it. I think it's a pickle file. We are here. Okay, now let's maybe we can move this to dataset. else do we say? The dataset configuration we loaded. We loaded dataset configuration is this function. Okay. This is we can remove this. We can do dataset path. Get training split. No. Dataset dot get metadata. Okay, I missed this function. For now, we are not using the test, so we are using it later. We have the dataset def get metadata self. And when we export them, it is save result. Save results. Wait. Prepare output folder. It's basically this. Save model. This is our model ID. Do I need to put the but I need more things. This is model save. And output path. This is the learning curves. We have here the output path, and we can remove okay, so we have prepare output folder, save model, save results. We can call, then we can move it from here, prepare output folder, and we can return the output folder. Prepare output folder. To return a path. Save model, and okay, chill, and save result. When we are going to change that name because it's off. But for the model we need the model, the preprocessor, and the data set metadata. The preprocessor, I don't have it anywhere, so basically it's copied from one path to the other one, but I don't care. Get processor. So the same model is, this is everything CLI. Then probably we're going to move these things away, and this can live here, but not the other ones. Let's move this outside model. Same model. Logging. Here we have the model. This would be ETF Keras model, no, Keras model directly. So in model we don't have Keras. Yes, okay, model. have the preprocessor, which is something, let's see, and the dataset configuration, which is a dataset configuration, and the output path, which is a path. The preprocessor is a what? What is the preprocessor? It's the study preprocessor. Okay, let's put it in here. And this one is a dataset v2. What a real good name. I guess it's a TF Keras dataset, probably, right? A TF dataset. TF dataset. In here. Okay. So, study preprocessor dataset configuration. This is an study preprocessor. This is the dataset configuration. From padly import path, and let's organize our imports so we can clean it a little bit. And our output path. Okay, so we have pickle dump, I don't know how I write this exactly. Yes, so here we can. This is basically copying it from one side to other side, but I would like to know what did I use for training the model. So when I do maybe I can have exported model. No, not them. Do I have the output path? I receive it as a parameter. This is self. This is self. This is self. But then I will have the static method load. I will load the model. No, probably it's not like this, the load. I do self model save. Keras.saving load model. I'm doing it here, right? In the notebook. Exactly. Keras load model. Now we have import Keras. We have the model, the preprocessor configuration. So when I do the predict model, I use just an exported model and study. Okay, so model dot preprocessor transform study. Okay, first of all, it's transform study preprocessor. This is just a study path. Okay. bracket column. So this study preprocessor is way too so basically I would like to have this can I create something like class study transformer? Okay, yeah. Basically nothing. This we have the scalar. Let's transform time series in the AR, right? And we do something like this, and we return time series. So here where we have our transformer will be this thing, and we can do something like this. And then we can just export this. Because this is study preprocessor is using just in the dataset creation. Maybe I can create a test for this, just I will do it later. I'm going to create a test for preparing the data set with some fake data. So now in the exported model I just use this. We have our transform, okay. So in our exported model it's not preprocessor but transformer. Here is like this. So when I train the model, do something like this. This is our exported model. So at the end it was more refactoring than doing actual evaluation. And then we have the save. Okay, so we have the model with our preprocessor, with our, let's call it a study transformer. We can, let's see, how do I open this? So okay, I don't exactly care. So this should be just the array. How do we open it is not responsibility of this function, because I will use it in prediction time. And then we have, if we want to actually move it away from Python, the thing, I don't care how to open the file for predicting, just having a clear structure of what are the steps to be done in order to have our prediction, our final prediction, let's say. So we have our time series. In our model we have our time windows length and our thing is, I'm going to predict in. So okay, let's first of all, out will be an array, be zeros, let's say, of shape 0. We are going to extract our time series. So I should predict one by one. Maybe I can. Maybe I can predict with more than one. Maybe we can. Let's do like this. Batch size. So it's going to be iterating in Windows. So I need to concatenate a few of these windows for E. So can I do? But group it in batches. I want to group in batches our batch size def group in batches. So I want to iterate. I can I yield it instead of returning it? So so this should be this should something like this. Okay, and the last batch at the end. So we have our batch, and then we reset it. I think this may work. For batch in exactly. No. This should be mp concatenate the mp expand dims time series axis 0 for in batch. We can print the time window dot shape predict no flatten predictions. Now we reiterate for in the batch plus I don't know this batch what it's doing, so let's do enumerate batch. No, not enumerate, just yes, enumerate. We have our window starting here, window start plus window length, it will be predictions. This is I'm going to, so I have, I said 32, it will be 32 times the window length. So I guess this should be something like this. We have to check the shape in here. And maybe doing plus, I don't know exactly. Maybe we can do exactly there at the end to something like this. Prediction, and then return our out. It should be MP in the array. Okay. Well, what I will do is to train a model so we have everything exported as we want. I have just a configuration file. I just tune a little bit in the training script for reading a YAML file and populating the configuration, and added a few things, but not that strange. I'm going to just train a model for testing. We have the U-time model. This is our I don't know what this is. We have our architecture defined, the learning rate. Then I will add some more things later. Okay, let's train this to see if we can have the model exported and then loading, and then try to test this function for having the prediction. Then when we have the prediction, we can use the other function we made, this one, to get the events. And then, okay, evaluate the model. Maybe, so I'm not sure if we should do I don't know if we should do non-maximum. So if we should get the events, so instead of doing this, just getting the list of events, but so they start at the end of each event, but mapped to the original coordinate, and then doing a maximum merge. I'm just doing like this, but we will see. For now, I will try to run. I don't remember the name. Oh my god. Good. This is stream.py line 67. Chill. What is the purpose of this? Lost plot, save it in. I don't see the problem. F string expecting. this is because of this quotes. Oh, I'm lost. I'm feeling really well actually in this moment. So maybe it's possible to tell actually. Okay, exactly. Dataset ID. I don't remember the name of the dataset. This is pH data. TF dataset. This is our ID. And then we need a config file with these experiments like this. Okay. And I upgraded everything, and the progress bar issue vanished. So good for me. Okay. Then I will resume later to see if we can just evaluate the model.